Hello everyone. Uh, this is a presentation of a temperature logging system, uh, which you go, had the requirements to set up a Raspberry Pi with some operating system and remote access, then to record and filter temperature from two temperature sensors, make some human-machine interface for alerting the user to the high temperature or to some high temperature as a threshold, and the ability to acknowledge the alarm to store the temperature data to a database and to some cloud service, to create a program for visualizing and analyzing stored data for a person, so you can actually view the data, not just see the database structure, and then set up a MQTT broker for controlling access to the server, and also add security to the system. And this is the system that was created. There is here, as you can see, buttons and LEDs, or a button and an LED used for alerting the user and for acknowledging the alarm. Then there is a TC74 temperature sensor, an NTC10K thermistor, which is connected to a MCP 300 and 3002 digital to analog converter, and all of them communicate with the Raspberry Pi. The Raspberry Pi in itself only communicates with the MQTT broker, which has been chosen to be a Nano MQTT broker, which is located on the server itself, not cloud driven. And it has some slave which communicates with a MongoDB database, and also with the data analyzer. And the slave also communicates with the cloud service, which has been chosen to be ThingSpeak. This is the setup of the Raspberry Pi. Here we can see the Raspberry Pi itself with button, the LED. Here you can see the TC74 temperature sensor, the NTC10K, and the DAC unit, all connected to different pins. This is the wiring sketch. You can see the MCP DAC unit, the TC74, the thermistor, button and LED, and the resistors used. These two are 10K resistors, and this is a 270 resistor. Yeah. For security, there are some different vulnerabilities with each of these parts. The Raspberry Pi is running a Raspberry Pi operating system, 64-bit, which uses an RPI firewall, and these are often exposed because many use default login credentials, and also because you need to keep updating them, and you often leave Raspberry Pi systems for just later or for embedded systems, so you don't often connect to them and keep updating them. And for this, or to solve this, I've placed it on a local network, which means it's not exposed to the internet and you can't connect to it directly unless you are connected to my or to this local network. It's thus meant to be directly connected to a server. And also all default security profiles have been changed, set up with a specific password and username. As for the Nano MQ, there is a default, it uses a default configuration file for setting these credentials, and the default is set to being able to connect with credentials, but you don't need to. You can also anonymously connect to it. This has been replaced with a specific configuration file for requiring login credentials. A default MongoDB local setup does not need login at all. You can just connect to it as long as you have the address it's set up with. For this, I have enabled authentication and stored the credentials in uh, environment variables, which is basically just a .env file, which I don't log to any uh, version control software. And then ThingSpeak last, it is the least customizable but most default secure. It uses a read and write API key, uh, and you also have to have the channel ID, and all of these are stored in environment variables in this .env file. Okay, live demonstration. You can see here, I've already started the system. You can see it's running right here. We have the MQTT broker here, which has acknowledged that it has uh, connected to different clients. Then we have here the slave, which just prints what it receives. And each time it receives something, it is specifically two sensors at a time, because I've set up this with two sensors. It's this TC74, this NTC10K thermistor. We can see here the latest data that they don't show the correct stuff. Neither of them. Right now I'm in my office, which does not have neither 30 degrees nor 18 degrees. It's probably around 21 degrees here. And that's what I've set my um, heater to. So these temperatures obviously need some tuning. And yeah, last we can see here that this is recorded to ThingSpeak, which of course shows the development of temperature over the time. I started this at a little bit, yeah, right, half an hour ago ish, and at around here, a little bit before, maybe somewhere around here, I turned off the heater, or I turned it down to 5 degrees. So it's slowly going to be decreasing over time. Okay, last thing here is or actually, first we can see the script running on the Pi right here. Here we can see first the seconds since last update. It only updates every 20 seconds because of this ThingSpeak limit, since I haven't paid for ThingSpeak. So we saw there that it updated, prints all of the data it sends then. And this first column here is just the first sensor, the TC74, and this is the NTC thermistor. The thermistor is very unstable, so I've set a limit on the filter to 18 degrees, and for some reason it keeps hitting this limit all the time. That's why it's locked here to only displaying 18 degrees. It doesn't fluctuate at all. Yeah. Okay. So here's the data analyzer. It right now it's set to only get data, which has TC74 sensor, since that was the most stable one. Although it does show a bit more temperature or higher value than I would hope. The database has not been cleared since I've done some testing, so the actual relevant info is here. This is what has been displayed, or should be displayed. It's the 19th today, and it was started at around 13, and right now it's 5 minutes past or 13:35. So we see it's slowly decreasing. It has the same structure here as the ThingSpeak plot. Yeah. And as for some here, it's just calculated some simple statistics. These aren't relevant for this data since it also includes the other stuff before. But yeah, the database should probably just be clear and it would show what you would expect. Okay, so it's the median here. This displays too many relevant variables. I thought I'd rounded this, but apparently not. And then the standard deviation and the variance. Yeah. Ah, right. You can't see the plot. This here is the plot I was talking about. Yeah. So started here at 13:00, and then right now we're at a little bit after 1:30. Yeah. Okay. So we can see the system works, but the sensors seem a bit unstable. They need tuning. And for the future, I would recommend removing ThingSpeak unless it's specifically needed for something for the client, because then you could update more often, at least without paying. And the security of storing the data in multiple places would be a lot better, uh, since we only store it in the database and not in a cloud service as well. I would also recommend setting up a live digital interface which can show the data over time, like ThingSpeak does, but also the mean, and probably good to have some sort of ability to show mean values, medians, variance, some prediction onto the future temperature, something like that. Maybe connect this to a heater so that you can control the heater or set some base level. Then finally, enclose the RPI in a box and solder the sensors to cables so that you can place these to different rooms. Right now it's just my office, but it could have been a living room or an outdoors area. I don't know. Maybe connect also a humidity sensor or something. And finally, this I started on, but there was some trouble with it. It didn't seem to work properly, but look into using Chrome tabs to automatically start the program on boot. So when you power up the RPI, it automatically starts to record, connects to the server. Yeah, summary. This was the task to create a temperature logging system. The temperature logging system uses an RPI, NanoMQ broker as Python-driven slave, which sends data to the database and ThingSpeak, and a MongoDB database, and then uh, analysis tool, of course. The security of the system is that NanoMQ and ThingSpeak are access protected now. The info is stored locally and in environment variables, the access info, that is, the data is storage is done by a slave and a broker, an MQTT broker. The Pi is on a local network, so it's not connected to the internet, of course. All data except ThingSpeak is stored locally, so can't easily get access to it outside of breaking my computer. And other companies can't get access to it, of course. And the default credentials and settings have been changed. And we saw some future changes to be done, make it more user friendly, and monitor multiple areas at once by making this stuff more less prototype, more actual setup. Yeah, this is the reference I used for the NTC 10K thermistor to set up the Steinhart-Hart equation to calculate the value. And that's it.